so you don't get that slightly de degraded stream from Twitch. Yeah. Okay. So, did anybody have any questions with the homework or anything like that that was put up or that was due on Friday? I didn't grade them yet, so I want to make sure there wasn't any lingering questions or if we are all good. Your next one I'll put up shortly. Um, it won't be a long one since you have your exam coming up soon, but it should start rounding things out. And my guess is that this week, either Wednesday or Friday, kind of depends, we will do some in-class stuff to do a little bit of requirements work on your teams. And depending on how far we get today, we will have a in-class assignment as well. Just go ahead and turn off Slack because it is blowing up in my ear. All right. That's about where we ended up. You know, we were talking about requirements, talking about requirement specs. Much less exciting than Binding of Isaac, but hey, that's the way it is. So we started categorizing these types of requirements here, right? So functional requirements, if you remember, they are very specific, very easy to quantify. Basically, they're what you give a programmer if you want them to develop a thing, right? And we kind of mentioned that non-functional requirements are higher level, more global to the project, more organizational. You know, they're going to give you that nice feeling of your project. It'll deal with performance. It'll deal with high quality, security, lots of those things that are kind of hard to quantify. We should be able to, but they'll be difficult. All right, so we started breaking them up into product-based requirements, into organizational requirements, external requirements. Um, kind of talked about these a little bit at the end last time, but maybe you have something as a company that you impart on all of your products. Maybe it's a particular level of security, or maybe it's a safety critical type of resilience. You might have external requirements coming from government agencies, right? You might need to be certified in such and such a safety designator, or maybe you have a security clearance or something like that. Requirements can really come from anywhere. Let's take a look at some of the product requirements here. We have usability. So who can use your product? Do you have to support accessible paradigms? Like, do you need users with screen readers to be able to handle your application? And if you're making a web application or a mobile app, probably should. Maybe it needs to be efficient in some way. You know, we can't all be blessed with 20 million gigs of RAM and deploy NPM applications. You know, maybe we have kilobytes or megabytes of RAM to deal with on an embedded system. So might have to be concerned with space or performance. Um, these can be non-functional requirements as well. How reliable is your product? 99% uptime, 99.9% uptime, things of that nature. We can write those into our requirements as well. And portability, this is kind of a big one these days. Can you use it on your computer, on your phone, on a tablet, on a Raspberry Pi, on a Game Boy, whatever it's going to be? Do you need to port this thing? Or take the flip side. Be very clear on what you are and are not supporting. We are only supporting mobile. We are only supporting PC or Linux or Mac, right? Anybody know why most of those web companies out there, by the way, will say we guarantee 99% uptime instead of 100%? A fun early morning question to think about. Because that technically would be a reliability statement. Updates, yeah. So if you're talking with, say, a cloud provider or a web host or a server host of some kind, right? And they will guarantee you 99.8% uptime. They do need to restart their servers every now and again, run software updates, like was said in the chat here. During that small window of time, there is a good chance your service is down, but usually it's at off times, right? You schedule that for 2 a.m. on a Sunday when nobody is awake or using your application, hopefully. And then you as, all software engineers, computer scientists, whatever your field is, you're probably up during that time anyway, and then you notice all the downtimes. All right, on the other side, we have organizational requirements. So here, again, these might be company specific. So could be things that you have related to how you deliver your software, maybe how it's packaged, perhaps how it is supposed to be implemented by the customer. You can also have internal standards that you follow as well. This will be ideally the same from project to project, but it would be a rigorous set of standards that you have to follow to make this project work. Again, non-functionals. We also have external requirements, and these are kind of the interesting ones to deal with. We talked about ethics very early on in the semester. We could actually write some of these ethics into our requirement specs. What are our intended goals for, minimizing harm to others or preventing data leakage, or, what happens if there is a fault found? We will create a chain of, escalation so that we can deal with this problem. We can actually write this stuff right into our requirements, and that's kind of interesting in a way that you can actually formalize these things. Interoperability. If you have a external, all right, that's what, okay. I'm not going insane. Okay. So Bluetooth headset and having multiple devices connected to it on Bluetooth is probably my big issue. I got a Hangouts message, and that made the volume in my headset explode, and it was like ear piercing. That's the issue. Turn off Bluetooth before class. Same for all of you as well. Turn your phone. Yeah, never mind. Anyway, interoperability. How do you deal with other applications? Do you have a RESTful API that you're providing? Do you need to reach out to another service via sockets? An external entity could be some other application that you're talking to. You also have legislative, so this is kind of a hot one right now. I know most of you probably have dealt with the GDPR requirements in some way, simply by seeing all those "Do you accept cookies for this site" button pop up, or "Be aware this is what we're doing with your data." That's the European law that was enacted for user privacy, but we are all seeing its effects over here. That'd be one example that every website needs to implement privacy agreements and things of that nature. So that could be something we write into our spec. Maybe you have a government body governing, specifying the safety requirements of your application. All right, we all saw, I'm going to guess you all saw that emergency landing that happened, so was it yesterday or 2 days ago? The airplane engine pretty much blew up while people were flying over Colorado. Right, safety requirements in engines need to be checked every single day. They need to be maintained in such and such a way. When they are out of service, we decommission them, things of that nature. Safety requirements, big deal, especially in safety critical systems. So effectively, we just have different categories is kind of what we're trying to get at here. And non-functionals, if you look at all these high-level categories, you can kind of see that they are very broad, right? They're not specific. If we are talking about, interoperability, for instance, if you have to reach out to another service or you have to support an application getting information from you, that probably will have implications for your entire data structures. If you have a database internally, how do you support security and access control? There's a lot of things that can go on with these non-functionals. So if we were to go ahead and spec these out, I kind of mentioned before we have that shell syntax with requirements, and again, you'll get some practice with that very soon. But for NFR updates, oh yeah, that was from a last question, just looking at the chat here. System shall be very user-friendly. What does that mean? System shall recover from a failure quickly. Okay, we kind of have an idea of what that means, right? If we have a critical failure, we can recover fast, right? But what is fast? What does it mean to recover? Do we reboot the machine? Do we reconfigure the application and redeploy it? Do we pull a new image off of the Docker registry and, rebuild it? What do we do here? They are not generally specific, but they should be verifiable in some way. So the system shall be very user-friendly. How do we verify that? Well, grab 100 users, shove them into a room, give them a $20 Amazon gift card when they're done, and say, hey, try out my app, see what you think. Ask them first before you shove them in the room, I suppose. Trigger a bunch of failures on your application. See if it recovers quickly enough to your satisfaction. Right? How big is a room? It depends. Depends how mean you are to your users. Um, as many as can fit per fire code. Let's go with that. Yep. So if you recover from a failure quickly, are you satisfied with what happens? System shall respond to requests quickly. This is again, a performance type of thing, right? If I have a web application and I'm getting requests from users, from phones, from laptops, from bots sending API requests, what does quickly mean? Does it mean 5 milliseconds, 10, or whatever feels good? Might go into that whole user-friendly thing where I click a button and I'm sitting there looking at a little spinning logo for 10 minutes and then finally it pops up. That's not great, but maybe 20 seconds is approachable. It just kind of depends, honestly, right? But kind of the key here is that the more abstract you are, the more imprecise you are with your requirements, they become very hard to verify. So user-friendly is very, very subjective. You could talk about more of a responsive type of design. You could talk about maybe response time windows, something of that nature. But kind of the key here is that you should be writing these requirements, functional or non-functional. There should be very little ambiguity in them. If they are specific, we know what to implement. If there is ambiguity, we have lots of questions in our implementation, and that's a problem for a developer. It should be quantifiable and testable. And the last word is the key word there because these requirements are going to be tested, meaning that you will run through a validation procedure or a verification procedure, depending on where we're at in the process. Does this test case pass? Does it fail? If it fails, which requirements were the problem? Because we'll have requirements tied to test cases. And if we don't know how to test a requirement, then there's a big problem in our process here. So be very, very precise. I'm not going to make you read this whole thing, but here are some NFR requirements from basically a random requirement spec I pulled off of Google. But here is an example. Employees shall be forced to change their password the next time they log in if they have not changed it within the length of time established as password expiration duration. Each unsuccessful attempt by user to access an item of data shall be recorded on an audit trail. So we very clearly have like a system administration type of thing happening here, right? Password requirements. Um, these are somewhat specific, so that's probably good because we are giving clear, distinct behaviors to follow based on what is going on. So change your password if they haven't changed it within X days, basically. And there is some flexibility here because we have some configurable parameters. Maybe it's set by the administrator, maybe it's set by the user, just kind of depends. But security-based, a little bit of flexibility in here, kind of decent non-functionals. Mainly these would be non-NFRs because they're more tied with like a security type of a thing. The level of detail in these almost makes them functional to me in a way. But feel free to peruse through these at your own leisure if you would like. Okay, so we've talked about functionals and non-functional requirements at this point, right? Two high-level categories of the requirements that you will have to write. Now, we're going to transition into requirements engineering. Think of it like software engineering, but for requirements. And for this, we're going to have two key activities we have to follow. There's development and management. Development means writing all of these things that we've been talking about so far. It's going to mean iterating them, revising them, verifying them, making sure that they are what you want to do. It is a process. Everybody is shocked. We also have management, though. So management is going to be very, very similar to configuration management. So if you remember from before when we talked about that, that was the entire ecosystem supporting software engineering, right? It's managing our artifacts, performing revision control, allowing us to go from step to step to step of the process because we have this framework to manage everything, right? Requirements management is the same thing, but for requirements. And the question for you all then is why do we need both of these, right? Can't we just stick our requirements in a revision control system and call it a day? Any thoughts on that one? I guess let me know if the question was okay or too ambiguous. All right, let me pop the question into chat. Because someone needs to check that requirements are being met. Absolutely, thank you. So now I guess let me step back a quick second because we can develop our requirements as, say, a Word document or an Excel sheet and just pop it into a revision control system and call it a day. But we need a lot more fine-grained detail over our requirements. So your point about making sure they're being met is absolutely on point. Requirements specify what we're programming. They also specify what we are testing. And by checking our software tests, we are basically checking that our requirements are being met. So think of it this way. Let's say you have a requirement spec that is 500 to 1,000 requirements long. Not out of the realm of possibility, honestly, when, again, you think of the level of detail we're specifying here. If we have 100 of them that are just either failing or we don't even have any test cases, we don't know if they're being met, right? Let's say we have an entire section on security. We have 0 test cases for them, which means we don't know if our application is secure or not. Just take it on faith that it's going to be okay. Development doesn't matter if it's not being looked over to see if it is doing well. Absolutely, you're all getting the point here, which is great. Oops, a little bit too far there. If we have requirements and we're not checking them, what's the point? Or if we have ambiguous requirements, it's going to be very difficult for your team to actually work on the thing. So you can kind of take it from both sides, right? Are we doing what we say we're doing? Or are we giving our team enough to work with so that they know what to build? Again, your point is very well spoken there. This entire process of developing projects is not just programming. There's all the other stuff that goes with it too, and requirements are a key aspect. So quick slider for you all. How's everything going so far? Just to break up class a little bit, I'm kind of curious. We are pretty much smack in the middle of winter in online classes. Um, just kind of curious how everybody's doing. Bit of an odd transition, but do feel like I need to check up on you all from here or there. Good. Getting into the swing of things. All right, that's good. So if things are going pretty rough for you, um, keep in mind you can always reach out to me, or there are, I know people at GVSU that will help if you are struggling. And um, I was not asked to put this in, by the way. This is a legitimate question for you all. So that's good. More or less, everybody's doing okay. Yeah, if it's any consolation, I'm not a fan either of how everything is. But the snow is nice. To me, at least. I like the snow. I did make it out to Lake Michigan, was it Saturday, I think? And it is insane what the beach looks like right now, if you are able to get out. It's like all ice halfway out to the lighthouse. But okay, that's if you are struggling, please get in touch though. I don't want anybody to struggle too much in here or have a bad time. Okay. Yeah, let me I think this is fascinating. So the only reason I'm kind of bringing this up, one, it's kind of nice to get out if you are able to. Is it in general? I think I popped it into. Yeah, here we go. So I've only ever been out to Lake Michigan in the summer, more or less. So this is what the beach looks like in the winter. So this is like way out past where the beach ends. Um, and it's a little ice cavern that was made just from the waves freezing. Yeah, you've got another one there. So this is like looking back. So this would be where the beach is. Lighthouse is kind of going out this way. Um, just insane. Like I've never seen. I've been up to Lake Superior in the winter, and it doesn't get like that too far out. It's pretty cool. I think anyway. It's good for the mental state to get outside if you can. For me anyway. Um, so a bit of a review, and we kind of talked about this just now, so I won't hold you to this too much. So non-functional and functional requirements. Functional are very, very specific. They tell us what to develop and what to program. And, some of not just programming, we can also have functional requirements that specify, hardware implementations, maybe interactions with devices. It just kind of depends, but they're very specific, very quantifiable, very testable. There should be zero ambiguity in there. Non-functional, these are going to be global requirements, and global, again, not worldwide, global relating to the entire project. They are going to be your illities. So I keep saying illities and then I forget every single list of the illities. See if I can remember, because 7 software illities you need to know. Okay, here we go. I swear I forget everything when I go on camera. Usability, maintainability, scalability, availability, extensibility, security, portability. So let me drop this into the chat because for some reason I keep forgetting it. If it ends with ity, generally it will be a non-functional, honestly. But portability, that's a good one that I keep forgetting about. They are going to be harder to quantify. They'll be harder to test, but they should still be testable. They should be specific enough that you can do that. It may take more effort to test, though, is kind of the key takeaway here. Functional is what is needed for the project to work. Non-functional are added into the project for added features and better performance. Yep, so that would definitely be one viewpoint there. We can do a whole lot more. Non-functionals are not just for features, though. They kind of take the functionals and really bring the whole project together in a way. So the functionals are your technical aspects. The non-functionals are going to be everything surrounding that. Performance, definitely one of those. Okay, now we're going to get into how we create these things. Okay, so I've been talking about it thus far like you just sit down and hammer out a bunch of requirements. There is actually, surprise, surprise, a process for developing requirements. And this is basically going to end up in your requirement spec. And we're going to not specifically follow this in class, but you're going to hopefully get an idea of what these are. So elicitation is our first one. I swear during class my kids go nuts. I don't know if anybody can hear that, but God. Where's my screaming goat? That's kind of what it sounds like in the background. Um, so elicitation is where we actually figure out which requirements we need. They could functional is to make the product usable, non-functional is to make the product good. Yeah, that'd be a summarization there. Yeah. Just trying to think if there's anything I'd have an issue with that. Functional are basically how you implement it. Non-functional, make the product good, make it usable. Eh, Yeah, package it up nicely. So that's probably one way to say it, yeah. Okay, so elicitation is where we figure out which requirements we need. Maybe we get our developers in a room, maybe we talk to our customers, talk to our clients. We try to get a feel for what is needed, and there is an entire interviewing process we'll talk about with elicitation. Then we're going to analyze them. We're going to make sure that they make sense. We're basically going to walk through each of our requirements, verify them, make sure they are doing exactly what we say they're doing, that there is no ambiguity or anything that is unclear. Basically, you're doing an editing pass over your requirements at this step. And if you discover a problem, go back and clarify. Ask the people who came up with your initial list, maybe their initial needs, their initial high-level goals, whatever it is. Hey, can you clarify this point? You asked us to make this thing support Android. Okay, well, which versions of Android? Do you want the latest? Do you want to go all the way back to Marshmallow? What are we supporting? Right? Give us more detail. And then you write that into your requirements. Make a new requirement. Update an existing one, whatever it is. Then, after that point, you actually write the whole specification and then you validate it. So basically, you get very high level ideas here. You start kind of, hammering them down in the analysis phase, get clarifications where you need, write the spec in a more formal setting. Maybe you're putting it into your requirements management system. And then you validate, which means line by line, go through a process of checking it. And then you see arrows back, where if we have to fix things, we have the chance to do that. Basically, it's like a very agile process almost. This is not something where like it's going to take years and years to develop these things. We do have the ability to go back, you know, talk to the customer at the very last stage and make sure type of thing. But once you get that requirement spec nailed down, you move forward in whatever software engineering process you have. Let me pop these clarifications up here. Get user requirements, understand and model, document, check that what you came up with matches the user spec. So fairly linear process unless you have questions that need to be answered. Okay, so as long as that makes sense, we're going to talk about the type of people that actually do this work, because maybe this is something you're interested in. Maybe you are more interested in fulfilling the role in a company where, maybe you don't want to do implementation, but you want to work in, still work in software engineering. You would be the type of person that could be a requirements analyst or requirements development engineer, whatever the role title is at the company. But what it kind of boils down to is that you're good with people, but you're an engineer. So your job is to basically figure out what all of the stakeholders need for this project. So you're going to talk to clients, you'll talk to customers, you'll talk to, the business people, marketing, the engineering team, you'll get everybody's input, talk to all the stakeholders, and then you're going to figure out kind of what is needed. So this might be a role, might not be a title. Again, it's company dependent. And you could be an engineer that gets forced to do this. It just kind of depends. Um, But basically your job is to get everybody's input and make this requirement spec. You will probably have help. You will not be alone in doing this because you need technical input, you need business guidance, you need marketing, everybody's input. But you're probably good with talking to people at this point. So this picture here is for a business analyst, but honestly, the idea is the same for a requirements analyst. You might do market research, gather data from all stakeholders, figure out if what they said is okay, enable communication, talk to the engineers, talk to the clients, talk to everybody you need to, and then eventually come up with a proposal. And then we kind of go through this whole process. But that basically happens at the elicitation phase. So what are we good at if we are going the analyst route? Again, you're looking at this list of bullets here. Lots of talking to people. Probably hear that one. That magic time of day. You're seeing interviewing, questioning, listening, facilitation, observation. These are all skills that you need to have if you're going to be dealing with other people. If you're the type of engineer who doesn't like talking to people, this might not be the role for you, which is perfectly fine. But you're probably really good at organization if you are going down this path. And if you see interviewing, questioning, and listening skills, that probably means we're going to be interviewing people, right? So that means that we are actually going to be systematically figuring out who wants what for a project. So the elicitation phase then is going to be probably the phase where we have the most, not the most communication, because there should be communication at all phases, but this is going to be the most interwoven communication, right? There will be discussions with clients, with customers, with every interested stakeholder, and you're going to be getting all of their input. Now, if you're going more agile, you're going to say, well, you should be talking and communicating, collaborating all the time, right? And yes, that's true, but you're still going to have to be doing something like this even in agile, and it will probably be even more communication intensive than the entire team is dealing with. So what do we have for elicitation? Let me pop all these up since I don't want them animated today. Some semesters I'm interested in animating slides, some I just want it all there to talk through. Anyway, so maybe you have a group workshop. Get all the stakeholders in a room or a Zoom session or a Twitch stream, whatever it's going to be, and get everybody's input. Have a very well-specified format of this workshop. We're going to start 9 to 10, coffee, 10 to 11, more coffee, 11 to 12, let's talk about requirements, and then the afternoon we'll do a team building session. Now, let's talk about the front end. Let's talk about the interfaces. Let's talk about the back end. Let's talk about how we're going to send data to and from different parts of the application. What do you want it to look like? What do you want it, so and so and so on. But everybody will have their chance to give input, and then we can hopefully get a picture of what everybody needs. We can also do interviewing. So do one-on-one or small groups where you, the analyst, are going to interview the interested stakeholders. Maybe it's very open-ended where you let them talk, kind of like a workshop except with less people. Maybe it's very closed-ended where you have a list of questions to get through and you don't give them a lot of wiggle room to expand. Which voltage range should this hardware system operate within? Okay. How many buttons are in the home screen? Are we going to make this a responsive web app, or are we going to structure it very specifically for browsers? Okay. So basically, do you allow the parties that you're talking to expand and give you lots of detail? Or do you ask for very specific questions? And based on that, that's also like structured and unstructured too, right? Very specific questions or not. If you ask somebody a very specific question, and this is part of dealing with people, honestly, if you ask very specific questions, you'll probably get very specific answers. If you ask open-ended questions, you can get a lot more of their personal opinion. Could be good, could be bad. If it's a very technical question, you want a very technical answer. But if you ask an open-ended question, you might be getting something of a non-functional requirement. Right? You start getting into things like performance or look and feel, things that are hard to nail down with very structured questions, right? So based on what your interview style is and what you want to learn, structure your interview that way. You can also do surveys and questionnaires. These are crapshoots in terms of how well people will respond. Usually you have to give them some kind of an incentive. And if you have a mailing list, you're working in the next indie darling game and you have a mailing list of users and you're trying to figure out what your stretch goals are. Hey, let's send out an email survey to everybody on our list. What would you like for level 10? And if you give zero incentive, you'll probably get very few responses. Just people that are bored and see, hey, I got a survey. If you offer them, hey, we'll put your name in the credits, or you can be a character, or here's a $10 Amazon gift card, you probably get a lot more responses, right? So with these, you're basically sending a list of questions out without expecting a response. So you have to be very clear with what you want. You have to give them a reason for interacting with you. And if this is in a work environment, they're probably getting a paycheck. Is their reason to do it? But you're probably going to get less responses, honestly, if you do it that way. We can also observe. So let's say that you are developing a new point of sale system. Okay, so it's, you're a cash working on software for the cash register, which, obviously we don't have levers and buttons anymore. They're tablets with nifty little apps on them. But you want to create an update, create a new one. What do? Let's go observe people at work. Here is everything that this group of people did during their shift. Here is what could have gone better. Here is what went horribly wrong. Here is what was awesome and we don't want to change anything. And you're going to do this over a period of time so that you don't get like a little snapshot, but you get hopefully as much information as possible. Also called ethnography. Basically, it's just the systematic study of people, their cultures, how they work together. Basically, you're watching people. You're not interacting. You might ask questions, hey, what are you doing? But you kind of do the fly on the wall kind of thing. Honestly, difficult to get good requirements out of that. Maybe you'd come up with a list of scenarios. So here are all of our use cases for this project. Let's write requirements based on activity X, activity Y, activity Z. When we get into use cases, this is basically what we'll be doing there. Look at our bug reports. Look at our feature requests. If we're in the GitHub world, look at our pull requests. Right? What are our requirements going to be? You don't have to pick one. You can pick multiple strategies. But basically, the goal is to get as many ideas as possible so that you can distill them into requirements. All right, 10 minutes left here. Makes sense so far. So we are basically in the first stage of requirements engineering, figuring out what we need to talk about. Again, if we go back here, these are all very people-centric. You should be reasonably decent at dealing with people if you are going to go this route. Depending on your project team, if you're a more agile, free-form environment, maybe you get stuck doing this and then you have to become comfortable talking to people. If you have a choice, make sure that you're good with interviewing, good with talking, dealing with phone calls, emails, Zoom sessions, that kind of thing. But good at organization is kind of the key takeaway here. So let's say that we get this long laundry list of user responses, stakeholder responses, whatever it's going to be. Your next step then is to classify them. So is this a functional requirement, right? Somebody wants X, Y, and Z to happen in this application. Is it a quality attribute, meaning is it kind of like a non-functional? Is it a high-level business rule where we are kind of either describing how we are interacting with our customers or how it's going to support our company's bottom line or so on and so forth, right? We want 500,000 people to download and install the app. That'd be a business rule. Could be a constraint. This autonomous vehicle we're speccing out should never crash into a person. Or if we have the option between crashing into a person or a wall, we're going to pick the wall every single time. So what are your constraints? Where are the boundaries of your system? These can all be requirements. They can be non-functional requirements, functional. Hey, maybe the things we gathered are not even requirements, right? Maybe it's going to go into a data dictionary. So data definitions. We're going to have a JSON document that is formatted in a particular format. For God, can't speak today. Formatted in a particular style where every single entry has an ID. Every single entry has a name. Maybe it's a NoSQL table it's going into. Maybe we're sending it to a RESTful API. Just kind of depends. But not strictly a requirement, but very, very important to understand. And maybe we came up with something during our workshop, our interviews, where we have this problem that we're trying to solve with our app. But it could be a technical difficulty to actually program this thing, right? So during our interviews and workshops and discussions, maybe there are some people who have some ideas of how to solve it. Okay, instead of a bubble sort, use a quick sort. Why are you doing that? Well, we're going to be sorting through 500 million records. You don't want that particular order of magnitude. I'm simplifying here, obviously, but if you go that route, you might start imposing unintentional design constraints. If I give you a very specific way to program something, that kind of goes into the more technical details where you may become hampered by that. Right? If I tell you to use a RESTful call, and if you're not familiar with REST, that's a like a web service way of interacting with applications. So you send like a URL with like /get/ID/5. Maybe that gets a value from sensor number 5 or something of that nature. Or if I tell you to use WebSockets, or if I tell you to use, I don't know, use Unity instead of Godot, use Pico 8 instead of Unity. I'm giving you constraints. They're solutions, but you don't have the creativity to explore other ideas at this point. Requirements should be really non-implementation specific. But at the elicitation phase, people might start giving you ideas, right? You're going to be dealing with technical people. One of the other things we have to do with our requirements elicitation, and we will, let's see, and here or here, one of these two, figure out who is actually going to be using your application. Not everybody who is a programmer is going to be a user. You are probably going to design an interface, design an application that you would like, but that your target user base may not like. That's the entire UI UX design space, honestly. But getting your users involved, and again, they're going to be stakeholders, right? Right? If they like your application, then you're going to have a much better application. And this is where we start trying to classify users. Are we expecting to have young and hip college students using our app? Is it going to be used by kids? Do we have to do any kind of parental guidance kind of monitoring of the data going into this thing? Is it going to be mostly elderly people using it? Is it going to be people who are classified as valid drivers, right? If it's an autonomous car. Basically figure out who is going to be using it. Okay, and then you can kind of develop your application towards those groups. And I'm not saying to like really stereotype or anything like that, but try to figure out, okay, what is their approximate level of experience going to be? Can you anticipate that your users are going to be, Bash power users? Are they going to be people who have never touched a phone before? How much hand-holding do you have to do with this mobile application or something like that, right? Maybe they are, could be that you're developing a embedded system. Doesn't have to be an autonomous car. It could be a, little Raspberry Pi project. Are you anticipating that your users know how to go to GitHub, clone down your software, and deploy it to a Pi? Or do you just give them an image to flash to an SD card? Again, it just kind of depends on who is going to be using your application. Maybe you're targeting power users in your company where they have high-level access privileges to the production database, and you don't want an intern getting in and deleting production. If this is like a nifty system administration type of tool. Again, just figuring out who is going to be using your software will be very, very helpful to you. And it will kind of help kind of constrain what you actually have to do with your projects. Okay, so we will end here with conflicts, and then we'll pick back up on Wednesday. One of the biggest issues that you're going to have with requirements is that your users, your stakeholders, everybody involved may have conflicts with what they want. Okay? So the business stakeholder may have completely different requirements than the developer. Think of every single game we've talked about where it failed on launch. Marketing and business wanted that thing out as soon as possible. Development said, we're not going to be ready for another 6 months, and don't put it out there. Business won because they have the money. Massive problem on release. User base hates you all of a sudden, right? So basically, how do we resolve these conflicts is kind of the key takeaway here. Is it accessible or flashy? Do we have feature interactions where X component and Y component are talking on the same communications channel, and by sending data at the same time, we have a maybe a crash or a stack tray or a brain's dead for the day, sorry. Basically, does the program crash because we're trying to do stuff at the same time? Segmentation fault, there we go. So we can have conflicting issues happening here, right? We want to do stuff at the same time, but going in different directions. How do we resolve this? We can categorize things into the essential category, where if we do not have this requirement, our product fails, doesn't work. Maybe this thing is desirable, but not strictly necessary, so it's something that's kind of a nice to have. Okay, well, after we've met our essential requirements, then we add in the desirable. Then we add in the optional, if possible. Right, and if you're dealing with very strong personalities, if you're dealing with people holding the money, you're going to have some flexibility with what your requirements are. And don't always have control over them, as we kind of see in the game dev industry, obviously, right? But conflicts are going to happen, and it's going to be how we resolve them. So what we'll do next time, I think, is we'll pick up with asking you what some conflicts could be. But be aware that it's not all hunky-dory in requirements elicitation land. You as the analyst don't always get your way. It's just how we deal with that, which is going to be how you become a good analyst. Anyway, questions, comments, or concerns from today? Or is everybody good? Come on, button. Get all the stuff he's doing with Firebase. All right, if we are good then, that's not the left slide. Where are we at with YouTube? Good enough. We'll end here. Hope you all have a wonderful day, and I will see you all on Wednesday. Bye, everybody. Yes, a list of topics. Is that up? It is not quite up yet. I wasn't sure how far we were going to get this week. It is going to be up. I will say it will be up by Wednesday. So basically, I've got a laundry list of questions which I will pick from. And you can all kind of go through that. That's pretty much what you need to know. But, yep. Awesome. All right. See you Wednesday, everybody.